Today is going to be another day with chapter 12, and we are going to continue to look at surface area of circular solids. So the last circular solid is a sphere. So characteristics of a sphere, it has no lateral edges. Notice there's no like sharp points or anything along those lines. All the radii in the sphere are congruent, just like all radii of a circle are congruent. It's the same thing with this three-dimensional shape. So how do we find surface area? Well, our formula for surface area is going to be 4 times pi times the radius squared. So R stands for the radius. And when you're looking at this three-dimensional shape, your center is going to be obviously in the middle, but then you can put your radius anywhere. So I can go from the center over here. That's a radius. Technically, I could have put it down there, there's another radius, or I could have moved it over here, there's a third radius. So all radii are congruent. So as long as you know what your radius is, all you have to do is substitute it into that formula. So if I'm asking for us to find the total area of the sphere, well, once again, total surface area 4 times pi times the radius squared. And notice that in this particular problem, they are right away giving us what the radius is. So all I have to do is take 4 times pi times 5 squared. All right, well, 4 times 5 squared is 25, and 4 times 25 is 100. It's still in terms of pi. It's important not to lose that. The 5 doesn't have a particular unit, so we would say it's going to be units squared, because once again, we're talking area. And that would be the total surface area of a sphere. Okay, there's also something called a hemisphere. A hemisphere is half of a sphere. So when we're finding the total surface area of this, we want to make sure that we divide the sphere in half. However, you have to realize that there's this extra shape on the bottom. You've got this circle that we also have to include in our formula. Okay, so if it says find the total surface area of the hemisphere whose radius is 8 millimeters. So notice that here from the center to a point, this would be 8. So if I was just to use that formula that we created, 4 times pi times the radius squared, that would give me the whole entire sphere. So 4 times pi times 8 squared, well, that would give me a value of, well, 4 times 8 squared would be 256, and there's still pi with it. But remember, I'm talking hemisphere. Hemisphere is half, so I'm going to cut that in half. When I divide that by 2, I have 128 pi. But that's not my final answer, because I still have this circle down here at the bottom that we have to take into account. So because I already know that it's a circle and its radius is 8, well, remember, area of a circle is just pi times the radius squared. So pi times 8 squared would get us 64 pi. So take the half that we created over here, and now the bottom circle, they both are in terms of pi. We get to add those together to get what our total surface area is. So 128 plus 64 is going to give us 192. There's still a pi with it. We were given units. Units are millimeters, and because we're talking area, those units have to be squared. But that's how you find the total surface area of a hemisphere. So just a quick recap of all the formulas that we've talked about so far. I would suggest that you pause this, write them down on the same sheet of paper so you have all of them with you at once. But remember, for both the types of prisms that we've dealt with, 2 times the area of the base plus the perimeter of the base times the height. We've got cylinders. We're taking 2 times pi times the radius squared plus 2 pi r h. For the cones, surface area, pi times your radius squared plus pi times your radius times your slant height. And then today we talked about spheres, 4 times pi times the radius squared. because what we're going to do now is we're going to be doing a couple of working backwards problems. This time I'm going to give you surface area, and you're going to be finding a piece of the formula that represents the surface area. So notice that in this problem, it's important to look at what's the shape we're talking about. Well, we're talking about a square prism. So we're talking about a prism. And so remember, based on the last slide, our formula for surface area of a prism is 2 times the area of the base plus the perimeter of the base times the height of that prism. Notice that I'm trying to find the height, so I don't know what h is. I am told that the surface area is 36 meters squared. So guess what? 36 is actually going to be plugged in for where it says surface area. So I'm going to have an equation that says 36 equals. Remember, B stands for the area of the base. Well, we're talking about a square. To find the area of the base of a square, remember, as long as I know what the side is, it needs to be squared. The last part of this says that one side of the square is 2 meters. So I'm bringing down that original 2, but hopefully we're okay with if I'm plugging 2 into my formula up here to find the area of my base, I'm taking 2 and I'm squaring it. So that's why the number 4 is going to go in that spot for the B. Plus, P stands for the perimeter of that base. Remember, perimeter is where you add up all the sides. In a square, all the sides are the same. So I'm adding 2 4 times, or I'm taking 2 times 4. So hopefully we're okay with that value. That has to be an 8. And then, like I said, we don't know what h is. Our goal is to solve for h. So we still have 36 equals. I can multiply. 2 times 4 is 8. Plus, we still have 8h. So if I want to start solving for h, two-step equation here. I'm going to have to subtract this 8 over to the other side. And so that gives me 28 equals 8 times h. Last step to get that height is I'm going to divide by 8. And so I get a height to be 3.5. And notice that this time we have units. I get to say that it's meters. Now I don't want to square it because I'm not talking about area. Height is not being squared. So 3.5 would be my height. In this last one here, it's talking about wanting to find the slant height of a cone, given the radius of the cone is 5 centimeters and the surface area of the cone is 90 pi centimeters squared. So if we're talking about the shape of a cone, we want the correct formula for surface area. When we're talking about a cone, it's going to be pi times your radius squared plus pi times your radius times your slant height. Now we're trying to find the slant height, so I don't know what L is. However, I know that the radius is 5, so anywhere that I see R, I'm substituting in 5. I'm also telling you what that surface area is. So 90 pi is going to go in for the spot of the surface area. Then we'll have pi times 5 squared plus pi times 5 times L, because I don't know what that slant height is. All right, now we got to start solving. So don't change the 90 pi. I can square 5. That gives me 25 pi. Over here, we've got 5 times pi times the slant height. Okay, my goal is to solve for L, so we're going to have another two-step equation. I'm going to move that 25 pi over to the other side. Those are like terms. They're both in terms of pi, so I get to actually subtract. So 90 minus 25 is going to give us 65, and there's still a pi with it. And that equals 5 times pi times the slant height. So if my goal is to solve for the slant height and it's being multiplied by 5 pi, the opposite of multiplication is division. So I'm going to divide both sides by 5 pi. Hopefully we're okay with the pi's canceling. And so that's going to give us then 65 divided by 5, which is 13, and that will be the slant height. Notice that we have units. They are centimeters. I'm not finding area, so I do not want to square those units. And that's us finding surface area.